Hi, I'm David Stringer, and this is R-2000, the Better Built House. Throughout the entire series, we've been looking at methods of reducing heat loss in R-2000 homes. Things like tightening the building envelope and allowing at the design stage for higher levels of insulation. We also looked at bringing fresh ventilation air into those tight houses without the resulting leap in heat loss. All of that's resulted in structures with a smaller heating load. In this program, we're going to look at the implications of that smaller heating load on the design and installation of the heating equipment in energy-efficient houses. I like the high-tech furnaces best myself, but we get back here in a couple of scenes. Right now, I've got to go find Oliver. Well, it's time to start looking at heating systems for R-2000 houses, and I'm going to be paying a little extra attention and looking on with envy as I have a 1923 coal boiler that's been converted. But I guess I'm going to be looking at this equipment from a slightly different viewpoint than the R-2000 builder.
R-2000 builders are taking a number of things into consideration when they look at heating systems. Remember the 5 key features that we've been stressing throughout the series. Now, one of those relates to heating systems. Can you remember it?
Well, I'd have to bet that it's the fact the house is airtight, and if we're talking about combustion, we don't want any of those nasty products of combustion to get into that indoor environment.
Right on. What that means is that unless we're using an electric furnace and an electric hot water heater, which of course don't require any combustion air, we're either going to be looking at induced draft or sealed combustion, alternatively a condensing unit. And we're going to be delivering combustion air to each of those systems.
Right, and my old monster in the basement doesn't require anything like that because most houses, conventional houses, are so leaky, but we're airtight. Now, can you rely on the mechanical ventilation system to supply air for combustion?
Adamantly not. If you think back to our last program, I think you'll remember why.
The mechanical ventilation system has to have balanced airflows. If we're supplying 150 cubic feet per minute to the house, we have to be exhausting 150 cubic feet per minute.
Right. Other exhaust requirements, air needed for combustion appliances, barbecue ranges, anything like that will have to be provided in another manner. While we're on the subject of ventilation systems, why don't we do a quick review?
A main feature of the Better Built House is the incorporation of a mechanical ventilation system. The properly designed ventilation system will exhaust stale, humid house air from those areas of the house where it's generated, usually the bathrooms, kitchen, and laundry room. Fresh air will be provided in sufficient quantity and then delivered to each and every room of the house. The ventilation system should operate on a balanced basis, supplying and exhausting air at the same rate. Finally, the ventilation system of the Better Built House will provide fresh air in a manner which meets the comfort requirements of the occupants.
Okay, well, kind of starting on the broad scale, we want to be really concerned about the health and safety issues, and I guess that's not just the kind of equipment we're going to get, but the installation as well.
You bet, and it's precisely because you know those health and safety issues have been addressed in an R-2000 house that they recommend themselves to consumers. Where would you start if you were going to design a heating system for one of these buildings?
Well, you know, if I wanted to minimize my design time, I'd go with electric baseboards. That's what I've seen. But I've also seen a lot of forced air as we've gone around to different places.
You know, interestingly enough, you'll find that there's a real regionality to the type of heating systems that are being employed. There are some areas where they only use electric baseboards. There are other areas where they use hydronic almost exclusively. But you really want to look at the distribution system. How is the heat going to be distributed in the building?
Are you saying that it's really up to just the preference of the kind of guy who's going to buy the house in your region, what kind of system you use?
Well, it's always the consumer's choice. But I suggest to you that you also have to look very closely at the type of fuel, the type of furnace, and the distribution system to determine what you're going to do. You want to see whether it's possible to integrate some of these systems and make them work better.
Well, I'm kind of ready to go back to that store and look at some of those different high-tech furnaces because I'm not too up on them.
Let's go. Well, David, we've got a whole bunch of furnaces to go through, so let's knock them down. What we're looking at here is a conventionally aspirating furnace. It has electronic ignition and a flue damper, but other than that is completely conventional. It is verboten in an energy-conserving house. The reason for that is that it relies on waste heat to create the draft in order to exhaust the flue gases.
In other words, the stack effect. They're hot, they go up.
Exactly. And the problem with it is that if other exhaust equipment is turned on in an energy-conserving building, it is possible to reverse the flue in this unit and bring combustion products into the home.
How would that happen?
If you turned on, for example, a Gen Air. Absolutely no place in an energy-conserving house. Look at the size of the heat exchanger here and compare it to the next unit we're going to look at. The heat exchanger in this unit is enlarged, which means that the flue gases are cooler. It is a more efficient unit. Efficient enough so that it is impossible to rely on the stack effect to exhaust the products of combustion. As a result of which, we've put a blower in this unit, which actually induces the draft and ensures that that takes place. This is very appropriate for an energy-conserving house because there's no way you can backdraft it. The blower will ensure that the flue gases are leaving the building.
Looking at the small outlet, does this thing need a chimney still?
It doesn't. It's possible, because the flue gases are now cool enough, to vent them through a small pipe, and you can actually credit the cost of this unit with the fact that you no longer have to build a chimney.
Okay, does this one still use room air?
It does, and in an energy-conserving building, you would have to bring exterior air to the unit to ensure that it would have adequate combustion air. Next unit up is, again, a large heat exchange area, again a very efficient induced draft unit, but in this case the heat exchanger has become so large that the flue gases are cooled to the point where we get a condensate out of them. This is an extremely efficient furnace and a very, very good choice, but again you must bring exterior air to the unit.
So the term condensing furnace means one with so much heat exchanger that it cools it.
Exactly.
That far.
This one is totally sealed combustion. Ideal for the job that we're trying to do because it is actually bringing its own air in from outside and again exhausting the products of combustion through a pipe. Totally outside the air volume in the house itself. Now all of the units that we've been looking at up to this point have been forced air furnaces. It's also possible to use this technology, which is somewhat different than the conventional technology we've been looking at. Pulse. What it's doing is actually it's a bit more like an internal combustion engine. You can use the same technology in forced hot water, or hydronic, and in this case we have a boiler that does exactly the same thing.
Where's my buddy the electric furnace?
Electric furnaces don't represent a problem in this case because they don't require combustion air, and they're 100% efficient. We're going to see a whole bunch in the field.
Okay. Well, I want to show off. I know everything there is to know about electric furnaces. They're like big toasters.
That's just about right. That's all there is to them. You can also look at baseboard electric heat, which are slightly smaller toasters distributed throughout your house.
Well, it seems to me that baseboards, if they work the same, would be a lot easier to install than a lot of ductwork and stuff.
Fair enough. Builders are always looking for the lowest upfront installed cost on things, but you've got to realize that in this type of housing, we are looking to distribute fresh air to all the rooms in the house. So if you're going to put in an electric baseboard heating system, you are also going to have to duct fresh air to the rooms in the building. And when you recognize that, a central electric furnace with the ductwork already connected to it can become quite a nice option.
Ah, so the ductwork, the plain normal ductwork that you would need for this system can just be used to also take the fresh air around. How do you do that?
Well, as we've seen, David, this is the return air plenum, and we are allowing fresh air coming into the building to enter the return air plenum, pass through that return air plenum into the bottom of the furnace, through filters, through the blower, through the coils, and then out through the supply air, which goes through the entire building and out to all the rooms.
Mm-hmm. Now, what about the fact with baseboards you can save money by turning off some of the rooms? There's sort of a zone control feature.
You also achieve some zone control in this case, or really balance in this case, because when the original mechanical equipment is installed, dampers are put in all the ducts going to the various rooms in the house. Those are then adjusted to give the entire system balance. And the homeowner has additional control by working with the registers that are in every individual room.
Well, if you're using this ductwork to take over the job of delivering fresh air, do you have to run that furnace fan and burn up energy all year round?
It's desirable to run the fan in continuous operation, and there is a price that has to be paid for that. But if you look at the advantages of having fresh air in all the rooms of the house and very nice even temperatures everywhere, it's not a very severe penalty to pay.
So I've been trying to find some disadvantages to this system, and I really can't think of any now.
Well, let's look very quickly at what the advantages are. It enables you to get a central distribution integrated system into the building, which is going to do the entire job for you. The second is that you get very good mixing of air. And the third is that you can actually do central space conditioning off the same unit, as in this case, where we have air conditioning. And all of that or additional filtering is done right here at this unit.
Well, you're a heck of a salesman. I'll take one of these. Same color, same size.
Well, before we do that, what I'd like to do is show you how you can go about matching the size of the furnace you need with the fuel type and source in your area, which is done on that computer program we've been looking at. I've got the computer up in the kitchen.
Well, I'll find the kitchen.
David, let me show you how you use the R-2000 to pick a heating system. What you do is you work with the degree days for the area in which you're located, in this case Ottawa at 4,673, and you have a design heat loss, which at minus 25 degrees Celsius is 4.63 kilowatts.
It's a lot of words. I just want to try to break them down. Design heat loss, so that means that at 25 degrees Celsius, which is the coldest day you're expecting, this house is going to lose 4.63 kilowatts.
That's what it's going to require.
Which magically then is the amount of heat, maximum amount you'd have to supply, so that's the size of the furnace, 4.63 kilowatts.
Not quite the size of the furnace. What we've seen in the past is heating ventilating contractors putting in very much oversized units just to be safe, sometimes oversized by 50%, and they knew they'd never be called back. In this type of house, that can cause a lot of trouble because the unit begins to cycle as a result of the fact that it's too large. You do, however, want to oversize the unit a little bit, say 10 to 20%. So in this case, we might be looking at a 5 kilowatt furnace because then we know we've got enough heat there.
Okay, a 5 kilowatt furnace. Now, just for me, how would that relate to the size of furnace that would be in the same house but without the airtight construction and the energy efficient construction?
Okay, conventional house, same square footage, same location, probably around 25 kilowatts.
Oh, now that number means something to me. Now that tells you about the amount of heat energy you have to generate. How do you tell what fuel to use? Can you fool around with that too?
We can do that too. If we go down to the bottom of this program, you're going to see that it's possible to input a number of variables here. You can input different types of energy sources, you can input different costs for those units, and you can also input the efficiency of the unit that you're looking at. So in this case, we have a natural gas furnace at 88% efficiency, which is giving us $131.40 a year for this building.
So the idea is you can play with all of those variables to get an idea, and oh, I guess you'd want to play with those variables and also keep the capital cost of the equipment, because we could probably install something that costs $3 million that wouldn't use much.
Well, and you're also discovering, I think, that many of at least the mid-range efficiency, if not the high-efficiency furnaces, pay back very rapidly. So it is worthwhile occasionally to spend more money up front in order to get a better performing product.
So I thought you guys only knew about nails and drywall and stuff. Look at that, the computer age.
Yeah, fair enough. Well, enough of the computer age. So don't you wish you had an airtight house, eh?
Well, you're slowly winning me over. I think seeing those mechanical systems, how kind of high-tech and well thought out they are, selling me.
Suppose you had to design a heating system for a new home. What would you select?
Well, I'd definitely go with forced air. And I think I'd check utility rates between gas and electric furnaces, because sometimes there are bonuses, and I guess it's different in different parts of the country.
Yeah, I think that's a very good choice, because obviously the forced air system enables you also to move the fresh air around the house. It's wise.
Right, actually that wasn't my first thought. I was thinking of the heat pump and the air conditioner and the electrostatic air filter.
Well, in your case that figures. What you're really looking at is integrating more things into your unit. And that's exactly what we're going to be talking about in the next show. Integrated systems. Systems, for example, that can use ventilation air to heat DHW. That kind of thing. I think we're...
So join us next week on R-2000, the Better Built House.
That's... sorry.